All right, friends and neighbors, it's now time for masks. Big idea number 3. We're going to call this one match criteria. So match criteria is how we decide what kind of address space we're talking about. So in addition to the simple idea of a network mask, which says I take my IP address and I AND it with my mask, and that tells me the network that I'm on, match criteria and the use of mask actually applies to a wide variety of topics, including access control lists, security kinds of things, but we can also use those with network address translation or quality of service, and also routing statements. But there are lots and lots of configuration lines that have some kind of IP address and some kind of mask. And really, together, those things constitute the match criteria. So again, the whole thing really comes down to what kind of address space are we talking about? What are we trying to match? So if we go back to our original classes of address, we remember that class A's have a 255.0.0.0, class B's have a 255.255.0.0, class C's have a 255.255.255.0, and the CIDR notation /8, /16, and /24 respectively. All right, now those default masks give us the size of each of our classes of network. No matter what network you're talking about, if it has that particular mask, you know exactly how big the network is. So, as an example of a class A, we've got the 100 network there. We know that the range of addresses goes from 100.0.0.0 to 100.255.255.255, or 16 million possible addresses. A class B always starts off with 65,000, and a class C always starts off with 256 because of the mask that goes along with that class of address. But we know now that we manipulate the mask all the time. And what this does is changes the address space. And so, as we've talked before, if we have an example of a class C with a /24, that has a range of .0 to .255 or 256 possible addresses. But if we change the mask to say a /27, putting a 224 in that last octet, the new range, instead of being 0 to 255, is 0 to 31. And that's because the mask changed the address space that we were talking about. In this case, it divided that by 8. So 32 possible addresses. Or we could steal bits from the network portion. So in this example, I've made it a /21 for a .248.0 ending to the mask. So the effect of that is to glue 8 class C's together. And so the range of addresses goes from 200, 200, 200.0 to 200, 200, 207.255. And so that's an important distinction. So that's the impact of manipulating the mask. What happens when we change the stuff out front? What happens if we change the first thing instead of just the mask? So, as an example, instead of starting with 200, 200, 200.0, we start with 200, 200, 200.35. And we use the same mask as in the previous example. Now the range shifts to 200, 200, 200.32 to 200, 200, 200.63. So still 32 possible addresses, but we shifted from 0 to 31 to 32 to 63. Why? Well, the mask didn't change, right? I had the same mask. What changed was what we did in the front. Overall, we changed that range of addresses that we were talking about. So you can change either one. Another example would be if we change from 200.0 to 200, 200, 199.0. And then we did the same mask, right? The same /21. And now the range of addresses that we're talking about is 200, 200, 192.0 to 200, 200, 199.255. And so again, the changing the mask changed the size of the address space. So in this case, we're still talking about 8 networks that were glued together, but by changing what we did up front, right, we changed the range of addresses that we're talking about, we shifted it somewhere in the address space, or somewhere we glued a different set of networks together. So the impact of the mask is still the same, right? You shrink the space that you're talking about, or you grow the space that you're talking about. But changing the part out front, the other part of the match criteria shifts where you're looking. Everything comes down to the ANDing process. Well, that's it for big idea number 3. The mask is not the only thing that you can change. And so together, when you take what's out front with the mask, that constitutes your match criteria. So it's really a combination of what you did in the first and the second fields. And then whatever you're going to use that for, right? Permit, deny, translate, whatever it is. But really, to understand what constitutes a match, what actually matches the statement, is based on what happens with the ANDing process. And so that's really, really important. Thanks for watching. Thanks for listening. Like and subscribe if I helped. And hey, may your packets always reach their destinations.